In this video, I'll take you through how I recreated the classic 2048 game. Let's get into it. Alright, let's start by making a folder, and let's call this scripts. And I'm going to create a game manager script here. Now this game's little, so I'm probably going to keep most of the logic just in the game manager in one central place, instead of splitting it across multiple files. And let's just remove this stuff for now. So what do we need? We need a serialized field, and this will be an int for the width. Let's default this to 4, and create another one. Let's call this height. And then let's make a function called generate grid. Let's actually call this directly from start. Generate grid. In here, we want to loop over our x, so our width, and then inside here, we want to also loop over our y. So if this looks a little bit confusing, you can go check out a more detailed description in the video up above, and then come back. So now we need to instantiate our tiles, or I'm going to call them nodes probably. So there'll be 4 nodes down and then 4 nodes up. So 4x4 square. So let's create a new script here. Let's call it node. And while we're here, let's actually also create another script called block. Like that. Now we need a visual for this node. So let's create a new empty object. I'm going to call this node. Let's reset that to 0. Then let's create a empty under it and call this the visual aspect of it, and then add a sprite renderer. Now we need some sprites to go in here. So in Photoshop, I have prepared 2 sprites, one for the block and one for the board. The only difference is the board has like this small rounded edge, whereas the block has a more rounded edge. I will include both of these sprites as well as a font, which I'm going to be using in a package file. So just check the description and you can just import those directly in. Just like that. So I'm going to chuck those sprites there. I'm just going to leave that there for now. So these sprites are actually at 2048, funnily enough, by 2048. So make sure you go to your 2D texture settings and ensure that pixels per unit is set to 2048. I made them that big just so that they're nice and crisp even when we're zoomed in. So on our node, let's put that in there. So there is our first node. And on the node object itself, let's attach the script there. And then let's make a folder called prefabs and plonk that in. Oop. And let's do pretty much the same thing for the block and add a visual underneath it. Could have just duplicated the other one, but live and learn. So this node I'm also going to use for the block, because why not? So I'm just going to chuck the node in there and then chuck the script on the block, and then let's make a prefab there. Cool, delete that from the scene. All right, back in our game manager. Let's create a new reference here, and this will be for a private node, and this will be the node prefab. So then here we can say var node equals, and we'll instantiate a new node of type node prefab. And the beautiful thing about this is we can actually use the world's transform positions as the X and the Y. So we don't even need to store the X and the Y on the node or the blocks. We just need to know their transform positions. So that makes it nice and easy. So we'll say it's going to be at vector 3, X, Y. Actually, we can use vector 2. And then rotation will be identity. And I'm sure you guys can hear the kids in the background. COVID is tough on parents. So, okay, so let's see what that does. Let's create a game manager script. A game manager object here. So game manager, chuck game manager on it, 4, and let's do the node. And if we just press play now, we'll see that it spawns our grids. So obviously that is not ideal, as we want a little bit of space in between it. So on our node prefab, go to our visual node. I'm going to just change that to 0.9 scaling. Obviously the Z doesn't do anything, but so there we go. Bit better. Now, it would be good if we could spawn a board on the back here. So on this board sprite, ensure that it's single. In your sprite editor, what you can do is you can actually move this in. So let's just say we'll move it 50 pixels on the left, top, right, and bottom. So now what that means is this will act as a constant on the corners, but everything in here will actually stretch, because we're obviously, it doesn't matter how far this is going to stretch, it's going to look perfectly fine as long as the corners don't stretch. So apply that. So let's make a prefab for that. Let's chuck the board on the screen, zero it out, and actually that's all we need to do. So let's just make that a prefab and delete that from the scene. Now in our game manager, let's add a serialize field private, and this can just be a reference straight to a sprite renderer. Even though this is a prefab, we actually only care about the sprite renderer, so we'll grab that directly. So we'll call this board prefab. So then down here under our grid, let's say board equals instantiates board prefab. Now, where is the center of the map? Right now, let's just do 0 and identity. So to get the center of the map, let's make a new variable here called center, and let's make this a new vector 2. And this will be the, actually we need to cast this to a float to ensure we don't lose anything. This will be width divided by 2 minus 0.5. And then this one will be float, it will be the height of the map divided by 2 minus 0.5. Like that. And now we can just chuck this right here, so that it will put it at the dead center of our nodes, like that. So let's just try that out. Back into Unity, and let's add the board. And then also let's go into the board, and actually I've got a color palette here, which I will include in the description, but I'm going to just be copying these hex codes like that. So that's the color that I'm going to have as my board. And then the node, I'm going to change the color to this hex code, just like that. Cool bananas. And also while I'm at it, I've also got a nice little color code for my camera. So I'm going to do that. Now let's see. And yes, you can see that the board is in the direct center, but it is not the correct shape, is it? It needs to be 4x4. So if you actually pull your board out here, and then you just try to stretch it like this and look at the corners, you'll see that they're not too pretty. So what you need to do is change it from draw mode simple to sliced, and now you've got this width and height category. And if you now just pull this width out, you'll see that it is using our sliced sprite that we did earlier. Okay, so make sure it's on sliced and then save your prefab again. And now in our script, we can simply say board. Now remember, we're actually directly referencing the sprite render as our prefab. So we can say size equals new vector 2, and we can just chuck in our width and our height. And that should do it just fine. Okay, so we need to make sure our board is on order layer 0. Let's make our nodes on order layer 1. And while we're at it, let's make our block on order layer 2. So now if we press play, yep, the board is in fact behind it. Now it would be nice if we can kind of make the same spacing around as well as we've got in here. So all we need to do really is, actually it would be better if we do this live. So if we click on our board and maybe make it like 1.05, no, yeah, about that, 1.03 should probably just about do it. That's about even, right? Yeah, that looks pretty good. So on our board, let's make it 1.03, 1.03. Now when we press play, yeah, just about good. Cool, so now let's center our camera whenever this gets generated. So we've already got our center here. So now we can just say camera.main.transform. dot position equals new vector 3. Now we need to do it in vector 3 because we need to move our camera back. We don't want to put it on 0z. So we'll say center x, center y, and then -10, which is the default position of the camera. There we go, and let's zoom it in. So you could put logic to auto-generate the size to ensure that the screen is kind of taken up, the game board's kind of taken up most of the room, but I'm just gonna hard code 2.5 for now. Perfect. All right, next step would be to spawn blocks on the page, on the board. So let's make a new private block. This will be the block prefab. And let's make a new function here called void spawn blocks. And let's actually take in a number here because we would like the first turn to actually spawn 2 blocks, and all the subsequent turns can just spawn the 1. So let's do 4 and loop over the amount that we've taken in, and we'll say block equals instantiates block prefab. And now we need a randomly selected node, which is free, don't we? So let's make a function that returns a node, get random available node. Now we actually need a list of our nodes. So we're spawning our nodes here, but we're not actually storing them. So let's make a private list, and this will be of type node, nodes. And then before we generate the grid, let's actually instantiate the list. Initiate the list. And now in this list, we can say nodes.add and just add in the node there. And while we're at this, let's also make a list for blocks. As we know, we're going to need them. And we may as well just initiate that list there too. Cool bananas. Okay, so we can say here, return nodes. Actually, let's not do it this way. We'll do it in a more efficient way. We can do this. We can say var free nodes equals nodes where, and then we actually need to know here if the node is free or not. So let's go into our node and remove this. And I'm going to have public block occupied block. So this will always be filled whenever a block lands on this node. So now we can say down here where n occupied block equals null. So we're going to grab all the nodes in the grid that don't have a block on it yet, and we want a random one. So we're going to go order by, and we're just going to say we're going to use a random value to order them by. And then, yep, so let's do that. So now we have a count here. So we know when the game ends, the game ends when there's no free available spots, isn't there? So we'll say if free nodes dot count equals, well, we could say 0 here, but what we actually want to do is we want to spawn a block first. We want to show that the board fills up. So what we actually want to do is we want to check if there's 1, because if there's 1 free node here, that's good. We'll fill the node, because this will always be just 1. Remember, because there's only 2 at the very start, so they're never going to have a problem here. So we check, is there 1 free node? Okay, cool, spawn it. But bad luck, you've lost the game. So here we'll just say here. And we'll say lost the game down here. So now that we've got these free nodes, let's say for each free nodes, and let's just take the amount that's required. Okay, so we don't need this for loop anymore. You can go away. We can just say block, and this is saying that we're enumerating it twice. So let's send it to a list, just so it doesn't have to actually activate 2 times. So now let's spawn our block, And let's put it on the node. And it would be nice if instead of going node.transform position here, as we're going to be doing this a lot, let's actually make a little getter here. So it will be public vector2, call it pos, and let's just return transform.position, just like a little helper function. So node.pos, and just identity is fine. Now, we need to give these blocks a number and a color. So let's create a little struct. This will be serializable. Public struct block type. Whoops, type. And this will have a public int value and a public color, like that. And then up here we can make a serialized list, private list block types. Whoops, that's meant to be serialized field. Okay, so now that we've got these types, we can initialize this block with a type. So let's go to our block script and let's create a little function here. And this will be our initialize function. So a init. And this will be a type, block type we'll take in, like that. And then we'll have a public int value here to store our value. So now we can say value equals type.value. And then we'll have a serialized field here, which will give us reference to our sprite renderer. And then we'll set our renderer.color equal to type.color. And I think that's all we need there. So on our game manager, now that we've got our block, we can say block.init. And we need a block type here. So let's create a little getter for grabbing a block type. So private block type get block type by value. And this will be the value that we're sending in. And then we'll return block types first. And then it should be type of value is equal to the value that we sent in. Now that we've got this block type, we can say get block type by value. And let's just say 2 for now. We'll just spawn 2s. So we're coming down here, let's actually call spawn blocks after we generate that grid. And we'll just say 2 for now, okay, because we're just doing this first test. We're grabbing our free nodes, okay, so that will basically be every single node to begin with. We're saying, okay, we're just going to take a certain amount from this free nodes list, and we're going to loop over it, and we're going to spawn a block in each of those. And they're also ordered randomly, okay, so we're grabbing them randomly, and then we're initializing the block. And then once that has finished, obviously this will come into play later. We're going to say, you know, if every single node is taken now, you've lost the game. So bad luck. And now let's set up our block prefab. So back in Unity, let's pull out our block here. Let's add a visual element to it. And while we're at it, let's add text to this so that we know what we're actually looking at. So 3D object, and I'm going to use TextMesh Pro. You can just use the standard 3D text. I prefer TextMesh Pro because it gives you far better options. If you haven't imported it into your project yet, simply click Import TextMesh Pro Essentials. That'll just import. And you can, in fact, create your own text assets with TextMesh Pro. Man, I can't talk. So Windows, TextMesh Pro, font asset creator, and you can just chuck in like a TTF here and then generate your font. But I've done that for you with this font asset that I gave you to import. So I'm just going to slide that into there, and it will be our new font asset, and I'm going to center it. And then let's scale this way down like that. And I'm going to change the color of my block just so we can see the text better. And it's also behind this. So if you remember, our order in layer for our block is 2, and TextMesh Pro actually also has that same setting. So if we go to our extra settings, you can see order in layer. Let's change that to 3. And let's just ensure that it's always going to be kind of in the square here. I'm going to auto size, and this, our biggest number will be 2048. So as long as it fits there, you can just click auto size, but you don't really want it being too big if it's just the one. So make max size something like 32 or something. Then in that case, they'll all kind of be uniform enough anyway. Also, let's give it like a little bit of shadowing. It'll make it look better. So down here in underlay, let's add an underlay, and then add just like a little bit, just like that. Just kind of makes it pop a little bit. Yeah, there we go. I'm gonna spin down my gizmos, they're too big. Cool bananas. So back in our block, let's make a reference here. Serialized field, private, text mesh pro. Yes, that one. Text, and then we'll say here, text dot text equals type dot value to string. There we go. So now our block gets initialized, and we've got the same one prefab for all of the block types. So that keeps it nice and clean. Now back on our block, let's send in our text, and just to make it clear, let's call this value text. Now let's save our prefab and get it out of here. All right, cool. So let's just make sure we've got everything hooked up. We've got this, which spawns our grid, centers our board, centers our camera. We're gonna find all the grid squares available. We're gonna spawn as many blocks as we've told it to, and that should work. And it's gonna be spawning blocks of 2. So let's press play, and that did not work. So what have we got? Block prefab. Did I not set that in our game manager? No, I didn't. So block in there and play, and that didn't work either. What else did I miss? We didn't set up our block types. Okay, so just expand the types there. Let's add our first one, 2, the next one will be 4, the next one will be 8, 16, 32, 64, 128, 256, 512, 1024, and the magic one, 2048. Beautiful. So now I'm going to go through and just add all the hex codes for this. I'm just going to speed this up because it will be boring as hell. Whew. Okay, got him. No, I missed one. Got it. Cool. All right. Now that we've got those, we should just be able to press play, and there we go. And also we need to downsize our blocks in the same way that we downsized our nodes, and we used, I think, 0.9. Yeah, 0.9. So let's go back to our block, visual aspect, and then change that down. Now that we've done that, we actually need to make this a little bit smaller. Cool. Press play. There we go. How's that look? Not bad. Pretty. Okay. So a few things. I noticed, I mean, I've only played 2048 a few times, to be honest, but I just thought it would be fun to make. But I did notice that they were not just spawning 2s, they were also spawning 4s, and it looked like they were a little bit rarer. So instead of just sending in 2, let's do a random dot value, which will give us something between 0 and 1 as a float. And let's say if it's over 0.8, let's give it a 2. Otherwise, let's give it a, let's give it a 4. Otherwise, let's give it a 2. So that should hopefully give us a 4 every now and then. So back in Unity, let's just try that. There we go. Beautiful. Okay, so now instead of just having this all kind of like just plonked, like saying generate grid, spawn blocks, let's create a little bit of organization here. So public game state, whoops, that is of type enum. So this will be generate level, spawning blocks, waiting inputs, moving, and then maybe win, lose. Yeah, that'll be good. Okay, so up here, let's say a private void change states. This will take in a game state, new states, and we'll have a private game states of type states, and this will set our state equals to this new state. Now, this is just a typical game manager. Again, if you don't know what a game manager is, I've made a detailed video on it, so go click that and come back. It's a very important game concept. So now we've got this, we'll add a switch statement here and we'll take in the actual state of the enum. And I'm just going to generate all these different switch cases. So that's just all of those. Now, instead of calling generate grid directly here, let's say in start, we're going to actually get the ball rolling here. We'll say change state and we'll say of type generate grid. So when the game starts, we'll call this function and it will be of type generate grid. So we're going to generate grid here. Now we're generating grid. So we're going to do all that, and we don't want to do this here. So we're going to say down here, we're going to say, all right, now that we've generated our grid, let's change state again to spawning blocks. So then in spawning blocks, we're going to go here and we're going to say spawn blocks. And here for the amount, we only want to spawn two blocks on the first turn and then one every subsequent turn. So what we need to do is create a private int, and this will be the round. And then when we're generating grid, this should almost be called setup game, but generating grid, like we're initializing all our stuff here. So let's always make sure that round is equal to 0. So we're on round 0. And then on here, spawn blocks, we'll say if the round is equal to 0, let's spawn 2 blocks, otherwise let's spawn 1. And we can actually avoid adding a whole an extra line somewhere around here iterating the round, because we can just say round plus plus. So this is going to say 0 first, and then it's going to add 1 to it for the next time it's used. But for the first time this is going to be called, it's going to just say, is 0 equal to 0? If so, 2. So that's just a nice little way to write it. As long as you know that you don't need this round object anywhere else to say round 0 during the round, let's just iterate it straight away. Okay, so that's enough for episode 1. It's probably getting a little bit long. So in next episode, we will learn how to actually shift the blocks and then combine them. And we'll be on our way to a pretty complete game. I'm only going to make this 2 parts. So stay tuned and I'll have the next one up in absolutely no time flat. See ya.